Hey guys, let's dive in. This is the fourth time I am recording this video today because I keep making bloopers. Here we go. Multi-step equations. Don't worry, today's video is only 59 minutes. Just joking. Okay, let's start with something simple. We're talking about multi-step equations, but let's step in with something easy. Simple two-step. I'm going to dive in here and I'm going to cancel that 7. Negative 3 and 7, good guy, bad guy, is going to give me a positive 4. I'm going to bring down that 2p I haven't touched yet. I'll even use some yellow here. I feel like Bob Ross. Throw in some yellow. Okay, I'm going to divide off that 2 so it cancels, and I end up with p equals 2. Now that's super simple, and you guys know that, right? It's just a two-step. Well, what if we now come up here, let me go ahead and solve this expression. Let's simplify this expression. Okay, so it doesn't equal anything, so we're just simplifying down as we always do. And when we're simplifying expressions, notice and remember, if it looks like this, step 1 is any distributing we have to do. All right, so if we got any distributing, make sure to do that. And as always, I'm throwing negatives in there to make sure you're catching those negatives. So we've got negative 18, and we've got negative 6p. We've distributed, we've broke those two out of parentheses jail. And now we'll just copy down what we had before. From here, I'm just going to look for any like terms and put those together. I've got some p's. I've got some more p's. 8 minus 6, well, that's pretty simple, 2p. Then I've got two constants, negative 18 and 11 is minus 7. And done, that's all there is to it. So if that was easy so far, which I certainly hope, we've got two steps solved as a basic two-step. We know how to simplify our expressions. By the way, let's add step 2. After we distribute, combine any like terms. Then, if this happened to equal something, if there happened to be something on this side of the expression, we would actually be at a two-step equation, and we could then move towards solving, which is an interesting idea. In fact, what if we do this? Oh no, take it all. Oh, for the love of Pete. Oh my goodness, look at that. When we simplify the expression, it becomes a two-step. If it's only a single variable expression, and this is true anytime you work with an expression, if there's only a single variable on that expression, and then there's a constant in there somewhere, everything is always going to simplify down to a single variable term when you combine all of those expressions that are those variables that are like, and a single constant term when you combine all those, which means we always end up at a two-step. So if this happened to be negative 3 from the beginning, you just solved a multi-step equation, whether or not you thought you could. We know this piece, that's solving a two-step. We know this piece, that's just simplifying an expression. Put it all together and just keep going, expression all the way to solving the two-step. You guys try these two right now, and then I'll come behind you and I'll solve them in a sec. And remember, number 1, distribute. Number 2, combine any like terms. And at that point, you will be at a two-step, so solve the two-step. I'll let you try these two, and then I will come behind you, and I'll do these two. Go. All right, if you're back, let's take a look. I'm going to distribute right here. So I'm going to end up with a negative 21 and a negative 15x. I'll bring down everything else. Cheyenne, pay attention. Haha, just joking. It's actually Camden that's not paying attention. He's probably still in bed. All right. Now, let's go to step 2, combine some like terms. Got some x's there, got some x's there. I'm going to put them together, negative 11x. And then I'll look for any constants that I have. I'll put those guys together, negative 21, negative 4, negative 25. Now, this is where I do see kids sometimes, when they're learning this concept, they'll try to pull this guy in as well, because it is a constant, and maybe that's the third constant we put in there, but you can't do that. Okay, the reason being, the big reason, is that this equal sign, it's kind of like a force field. You can't cross that with any type of like term. That concept doesn't apply. Oop, that's not going to work. I got to erase this guy. Okay, so we can't do that. We can't cross that force field. The negative 58 has to stay on his own side of the equation. He's got to stay here. There is a way to move it across, and I'll show you that next lesson, but you don't want to move it across. You want to solve for x, so you need something to stay on that right side of the equation. You need that negative 58 to be calculated into the final value, the final solution. So right here we end up with a two-step equation, okay? Now you just apply your two-step skills. I'll add the 25 to cancel it. Always the add subtract term first. And what do we get? A minus 5, 3, 5 minus 2, 3. There were more bad guys, so I'm at negative 33. I'm going to bring this guy over so things are a little closer. And all of a sudden we're down to a simple one step where the 11s cancel, so do the signs. Signs cancel again, and x equals 3. Good job. Hopefully you were tracking with that and it made sense. Okay? Remember, do not let this be combined with other like terms. Okay? Anything on this side is on its own side of the equation. It needs to stay there. Okay? The two sides are separate. You can combine like terms on just the right side if there's something there, but it's got to stay separate from everything on the left. They're their own kind of individual expressions that you work down to a two-step, and then you solve from there. All right, let's do number 2. Again, I'm going to distribute. I move the variable and everything over to the right side. Did you guys notice that? Did that throw anybody? This equal sign puts all of our work on the right this time, and the answer, the eventual solution, that value by itself is on the left. Hopefully that didn't throw you. You do all the work exactly the same. Negative 4 times 3, negative 12p. Negative 4 times negative 5, positive 20. Now I'm just bringing down everything that was not touched yet, that I didn't distribute, and I continue working. Watch all those negatives. That's another thing I'll see kids do as they're learning these skills, is they might miss one of these negatives when they recopy things. So watch all the negatives when you're copying between each step. All right, like terms, I've got some p's and p's. Negative 16p. Any more? And there's a lot of p today. 11 and 20. I'm going to move them over to here. You can put them wherever you want, but I'm just in the habit of seeing them on this side. So I'm going to put my constant term on that side. It doesn't matter if you put it on the front of the negative 16p. Okay, look at that. Where are we? We're at a two-step. By doing those simplifying steps of distributing, then we combined like, we find ourselves at a two-step. And that will always be the case with a typical multi-step equation. Those two steps bring you to a two-step, solve the two-step like you always would. All right, get rid of that 31. That's the add subtract term I'm going to cancel off. Those are bad guys and bad guys, which is going to make 48 bad guys. Bring down that negative 16p, so I can now divide that off. Remember, those guys are multiplying, so I have to use division to cancel them. 16s cancel your signs. P equals 48 divided by 16. P equals 3. How'd you do? Why are you talking to the computer? I'm just a video. Okay, next. All right, this is the second piece of today. Notice these two real quick. Take a look and notice how they're similar or different. Don't worry about the negative 3 on one of them and the 8 on the other for like the single value by itself. But look at everything. Look at everything on this side. I use the same values, but notice how they're set up a little bit differently. That's important. Okay. On the right side, let's start there first. The add subtract term is by itself, and so you would get rid of that guy first. You would minus 12 like you always do, and it cancels. Do the same on both sides. So we end up with negative 4. Recopy everything. And now we're just at a... oh, and by the way, even this one on the right is new now that I think about it, because you've got something multiplying with p and dividing with p. So technically, you could go either way at this point. We could divide off the 8 because it's multiplying, the negative 8. We could also multiply to cancel the 4 because it's dividing with p. You have to do one step of each. I'm going to do the 4 first when I multiply. And then I end up with negative 16. Divide off the negative 8, done. So that's probably not much that's new there, except you did have the negative 8 with the p over the 4. But this should look pretty usual for you. You cancel the add subtract term first. Now look at the left side. Some of us might be tempted to do something like this to start the problem. Okay? You can't do that. It will actually run you off course. It'll mess things up. The reason for that is because the fraction bar extends under that plus 12. That fraction bar is under everything, all those terms that are on the top. They're all included. Another way to say that is, it's as if we have we have invisible parentheses grouping everything on top of that division bar. So the 4 in the first problem, this 4 was only dividing the negative 8p. That's it. So we could cancel the plus 12 and then move to the other piece. But now on the left, that 4 is dividing the negative 8p and it's dividing a 12. So they're locked together. This is really like an example of reverse distributing. The 4 is distributing its division to both of those terms. It's like they're locked up in parenthesis prison again. So we have to break off the 4 before we can work inside. So in this case, we're going to cancel that 4 off before we get to everything on top. Haha, 4 pun intended. And since it's multiplying, since it's dividing, we multiply. Okay. Notice you're not doing any different math. You're doing a different order. Okay. We had to cancel off that 4 first, which broke them out of their parentheses, and now I can do my typical solving. A little speed solving here. Okay, I know you guys have seen that basic two-step solve 100 times now. Okay, so notice whether or not there are multiple terms on top of that fraction bar. If there are, they're locked up, and you've got to cancel or get rid of whatever's locking them in there, which is that value below. You've got to cancel him first. Whereas on the right-hand side, only the negative 8p is on top, which means we could go ahead and start here, and we'd start with our add subtract term like always, and then move over. All right? I feel like I gave you guys enough on that last one. You probably don't need another example. Go ahead and do the you try right now. Go. And of course, I'll go through afterwards, but you do it first. All right, let's dive in and see how you're doing. Now, in terms of this problem, this guy's by himself. He's not on the fraction bar, so I can start with him like I always would. I'll add the 5 to cancel him, do the same to both sides. Oh, by the way, I think I just probably hijacked you a little bit, and you probably just wondered about something. I'll show you right now. So I've got 4p minus 3, and it equals 13. I'm just going to copy that 13 down a little farther so I have more room. Okay. So we're here, and at this point, we can't get to these guys because they are on top of that fraction bar, so I'm going to cancel that 6. It's dividing, so I'm going to multiply. So it's time for him to go, so I can get to everything on top. And so now I've got the 4p minus 3 equals... So I'm going to do a little distributive multiplying in my head. If you guys want to learn that trick, it goes like this. I'm going to multiply the 6 times the 10, which is 60. In my head, I'm holding that number 60. Then I'll multiply the 6 times 3 is 18. So in my head, I'm going to put them together. And I see it's 78. Okay, that's a shortcut. If you've got bigger numbers to multiply, you can split them and then add together the two pieces. All right. So we're here, and now we're just solving a normal two-step. And you probably got a fractional answer, which made you think you did something wrong. Don't worry, you didn't. I was introducing something that happens or can happen often with multi-step equations, which is that you will often possibly get a fractional answer. And the reason for that is just that, frankly, your teacher is lazy. I have to come up with all these problems a lot of the time, ahead of time, and to work out a whole number solution to a multi-step equation it just takes time. And so eventually I'm just going to start throwing these out there, and we end up with 81 over 4. Now technically that is the solution. You're done. But you can, oh my gosh, move. You can rewrite it. How many times will 4 go into 80? It goes in 20 times. That's 80 out of the 81 that was on top, and there's 1/4 left over. So if you rewrote it mixed, it would look like that. But I would take this on a quiz because that is correct. It's just not written in a mixed number form. So if you're working with any multi-steps from here on out, on homework, on a quiz, or even a two-step, and it comes out fractionally, that's okay. You could just stop right here if it doesn't divide, and that is your solution. All right, I'm going to go back up to that first example that I didn't do yet, and if you want to work that out for some extra practice to help with this concept, go for it, and I'll go ahead and solve it right behind you in just a few seconds so that you can see if you need that extra help. All right, so if we dive in here, at 2 I can cancel first because it's out by itself, and I'm going to just rewrite the rest of the problem on this side because I have a little more space, I think. Okay, all I did was transfer what's left over to this side, just so I could have a little more room to work, and I'm going to erase some of that out of the way. Okay, now the 5 has got everything locked up, so I've got to use the 5 to cancel. So we end up with negative 40. And now we're down to our two-step. Okay, so I'll add that 4 to cancel on both sides, which gives me negative 36 equals negative 3. Hey, this wasn't even supposed to work out to a whole number answer. I just threw something down and I thought by luck it wouldn't. Okay, it did come out to a whole number answer, but I didn't expect it to. All right, here is tonight's homework for you. I did not find some stuff in the book that I wanted to use, so they're right here. Pause the video, copy them down. I'll have the answers and any work-throughs for you tomorrow on the or Monday on the video. All right, copy it. Bye.